Welcome to the Transum Podcast, a monthly roundup of the new features on the transum.org website, providing mathematical puzzles, games, learning activities, and the ever-popular mathematics lesson starter of the day. Here's your host, John Tranter.
Welcome to episode 18 for March 2016, and this is the Transum Mathematics Puzzle Podcast. And as it's called Puzzle Podcast, we'd better start off with a puzzle, I suppose. What is the smallest square number greater than 1 that cannot be expressed as the sum of two prime numbers? Okay, the smallest square number greater than 1 which cannot be expressed as the sum of two prime numbers. And the answer will be at the end of the podcast when you've had a little time to think. There's nothing like a good puzzle involving prime numbers. And that was nothing like a good puzzle involving prime numbers. But anyway, opportunities to remind pupils of what prime numbers are and how important they are as the building blocks of the number system are perhaps too infrequent for many pupils. So Transum has a number of activities which can be found by typing the word prime into the search box at the bottom of any Transum page. And it's one of the few school topics that occasionally appears in the news. So I was very happy to hear the QI Elves talking about the latest prime number on their podcast called No Such Thing as a Fish. QI is the TV program shown on the BBC, full of very interesting facts, and the QI Elves are the researchers, the people who dig up these facts. So they talk about the latest prime number and reveal quite a few interesting things about prime numbers which are well worth sharing with your pupils. Here we go.
Okay, so fact number 3, and that is Andrew Hunter Murray.
Okay, my fact is that this week we have discovered the largest prime number ever. We would have discovered it in September, but the computer which found it forgot to tell anybody. So this has happened. So there are computers all over the world looking for new prime numbers, and they're up to really enormous ones now, and they're very useful in encrypting stuff.
Yeah, they're called GIMPs, aren't they?
Yeah. Something massive prime.
Great internet Mersenne, which I think, Mersenne prime search.
Yeah, Mersenne. It's Mersenne primes. So these are prime numbers named after a French guy called Mersenne.
Yeah.
And you can download a computer program onto your computer, and it will look for these prime numbers. And if you find one, then you get like $100,000 or something like that, or $100,000. And a lot of people have put it onto the computer, but the people who found it this week or last year or whenever it was, they have so much computer processing power that they've managed to find loads of them.
Right.
Yeah, I think they found like 4 of the last 5 or something like that.
That's right.
Wow. Yeah.
So the new one, I'm going to read this out from here. The new number is 5 million digits longer than the previous largest one. It's 2 to the power of 74,207,281. All of that minus 1.
Yeah.
And it's if you were going to write it out, and you could write 10 digits in 4 seconds. This is a calculation by a New York Times correspondent. It would take you 3 months without slowing down.
Yeah. And it's got 22 million digits in it.
Like my phone.
It starts 30037641. Stop me when you get bored. And then it ends 007-339-1086-436-351. And for people at home...
So you've just given away the ending. There's no point in reading the middle now.
For people at home, we edited out the other 22 million I just didn't say. And you can download the actual number and get it on your computer and have a look through it, which I did.
Oh, great.
It contains my 6-digit code to access my bank account.
Whoa, James, don't say that.
And
people will know.
It contains it 21 times.
Wow.
That's how big this number is. It contains my library number twice, and at one stage it has 8 sevens in a row. So I'm just giving you the edited highlights here.
was watching an interview with the guy who discovered it, or rather the guy who set the computer up that discovered it, and there was a moment that, like, this is amazing, this is a big new prime number, it's beyond any that we've had before, what can we do with it? And he was like, we have no idea, literally nothing, it has no point, it has no purpose.
So most of them can be used for encrypting things on computers.
Yeah.
Unfortunately, this one is now such a global celebrity that it will be noticed immediately by hackers. So if you have a key that's several million
The
digits
thing
long,
is, you use prime numbers in encryption by taking two prime numbers, multiplying them together, and then it's finding the factors of that secondary number. Now, if you have a number which has got 23, 24 million digits in, you know that one of them must be this number. So everyone knows that it must be this one, so it's really easy to crack. So the only time this will be useful is when we get some even bigger numbers that we can use, which we will do one day.
Yeah.
Right.
I like that. I'd never heard prime numbers described like this, but they're the building blocks of maths, really, and they're the equivalent of atoms in science, because prime numbers are, because nothing goes into them, everything else is a factor of something else, so everything else can be split up, but you can't split up a prime number. I like that, they're the equivalent of an atom. And something else I didn't know about prime numbers, because you think that they're kind of so randomly distributed, if we've taken this long to work out what, the pattern is that all prime numbers, if you square them, are a multiple of 24 and then adding 1. Now, you
Apart
just
from
write that down.
Not the really small ones,
Not
like
the ones
2
under
or 3.
5.
No, but
Yeah.
5 is...
Yeah.
Right,
Anything over 5.
7 is...
Oh, God, are we going to go through them all?
Wait, what was
11
it?
is, 13 is...
Whoa, 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 whoa. 11 is...
So they found this using the GIMPs, the software, and this is the weird thing. The weird thing about GIMPs is, if you go onto Google and type the word GIMPs into Google, all of the first 5 things that you get are about this prime number thing.
You are listening to the Transum podcast. You can find Transum Mathematics at www.transum.org.
So don't forget to include some of the amazing facts about prime numbers when you are teaching the basics. It will capture the imagination of some pupils and ensure the learning is long-lasting. So what has changed on the Transum website since the last newsletter? Well, each page gets a makeover when it reaches its 3rd birthday, but also new content is being added every month. A similar shapes self-marking exercise has been added. This topic is one that typically defies intuition. When the dimensions of a solid are doubled, its volume increases by a factor of 8. And facts such as that are really quite hard for pupils to appreciate. Another self-marking exercise provides practice in finding the nth term of quadratic sequences. It's not every pupil that needs that skill, only those on course for higher grades, but this randomly generated quiz should be a useful tool to the busy teacher. The Human Graphs visual aid is proving to be hilarious. It has not failed to bring a smile to the faces of all those who've used it so far. It makes fun the process of recognizing the shapes of the graphs of simple polynomials and really breaks the ice in any maths lesson. So check that out. It's called Human Graphs. The ludicrous puzzle challenges pupils to arrange the given numbers on the cross so that the sum of the numbers in both diagonals is the same. It is quite easy to find one solution, but finding all the possible different solutions is another challenge. Once the basics of arithmetic with negative numbers have been mastered, the negative magic puzzles will provide some of the practice needed to consolidate the understanding. This is another randomly generated self-marking activity that can be used many times with the same pupils. There are many versions of the Tower of Hanoi puzzle on the internet, but this one on the Transum site that's just been added encourages pupils to find a pattern in the number sequence generated with the minimum number of moves. There are a total of 10 different levels, but it is not expected that anyone will have the time to do the higher levels, as far too many moves are required. In fact, level 10 of this puzzle featured in an episode in 1966, which actually I remember. of Doctor Who in a story called The Celestial Toymaker. The villain forces the Doctor to work on a 10-piece Tower of Hanoi puzzle, which they call the Trilogic game, and if the Doctor manages to complete the puzzle, the Toymaker's domain would disappear. Anyway, finally, sometimes the simplest ideas are the most useful. The place value chart is certainly nothing new, but the functionality it provides may help you make sense of this important yet basic topic. Okay, your thinking time is up. The answer to the puzzle posed at the beginning of this newsletter is 121. Did you, in the process of arriving at this answer, notice that every other sum of two primes adding up to a square number included the number 2? Can you think of an explanation for that? Enjoy March. Bye.
Thank you for downloading and listening to the Transom podcast. You can find the website at www.transom.org, where you're welcome to use all of the activities absolutely free, or jump in with both feet and become a Transom subscriber.